The new section is entitled Sample Space and Events. We'll just touch this topic, but sample spaces are going to come up time and time again. How about we list the sample space for each experiment? You conduct an experiment and there's possible results. The set of all possible results is the sample space. You toss a die, the sample space, well, let's do that one. What's the sample space if you toss a regular die? Either you'll get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. The sample space for the event of tossing a die is right there. What's the sample space for the experiment that concludes the sex of a child? You do an experiment. You go up to somebody and you say, what's the sex of your oldest child? And either they will tell you a boy or a girl, or they have no child, or don't bother me. But let's assume they have a child. I guess the best way is you go up to somebody and the next person who walks by you, you're going to look at them, and the experiment is the next person who walks by you, you're going to denote their sex. The sample space is B or G, boy or girl. That's the only things you might write down, a boy or a girl. The next experiment is tossing a single coin and observing the outcome, head or observing the outcome. What would the sample space be? T or H, tail or head. You roll 2 dice. What might the sample space be? You roll 2 dice and you record the outcome. What might it be? Well, the first die can have a 1 and the second can have a 1. Or the first has a 1 and the second die is a 2. Or the first die is a 1 and the second is a 3. All the way up to the first die is a 1 and the second one is a 6. Or you can have the first one being a 2 and the second die being a 1. Or the first being a 2 and the second one being a 2. All the way up to the first one is a 2, the last one is a 6. All the way up to the first one being a 6 and the second one being a 5. And then the second one being a 6, first being a 6, and the second being a 6. There are 36 of them. I hope it's clear that I did not write down all 36. The 3 dots generally go in front. How about the experiment is to record the lifetime of your computer in years. Well, you can call it the set of all x's such that x is greater than or equal to 0. Your computer could last forever and ever and ever. It could not work out of the box, hence equal to 0 years. The set of all x such that x is 0 or more. Okay. Now, let's play some games with these problems. Each of these. Now, turns out that an event is the subset of the sample space. For example, the event that you have a boy is the subset of the first problem we did. The first problem is that the sample space is the sample space for the experiment, the sex of the next person who walks by you, is either B or G. But an event is a subset of that, just boy. Suppose I tell you E is the set of H, 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 T. And this came from the sample space. I don't know if we did this one. I wonder what happened if we did do it. We talked about tossing a coin. At least I meant to talk about tossing a coin. You toss a coin, either you get a head and a head. I don't remember writing this down. A head and a tail and a head, or a tail and a tail. Those are the four outcomes if you toss two coins. The event here, how would you describe this event? The answer would be, this is the event where the first toss is a head. Remember, when I have something, comma, something else, this is the first outcome, this is the second outcome. That's the outcome of the first toss, it's a head. That's the outcome of the second toss. First toss, second toss. Oh, the first toss is always a head, and the second toss can be a head or a tail. That's the event where the first toss is a head. If I said E is equal to 3-1, 3-2, 3-3, 3-4, 3-5, and 3-6. This is a subset, and I'm telling you this. There's no other way you should know it. This is a subset from the experiment tossing two coins. How would you describe this event? The answer is the first die always is 3. The first roll is 3. You toss two coins, two dice, one after another. The first one is 3, and then the second one's a 1. Record it. Do the experiment again. The first one's a 3, the second one's a 2. That concludes the second experiment. Perform the experiment the third time. First toss is a 3, the second toss is also a 3. Perform it again, the experiment. First toss is a 3, second is a 4. If I tell you E is the set of all x's such that x is in between 0 and 8. And this had to do with your computer life. Well, this is the set of all computers that live between, or have a lifetime between 0 years and 8 years. So an event is a subset of the sample space. The sample space is everything. What are all the different possible outcomes? Now, there are some facts that we should know. If you take a finite union of events, the union as I goes from 1 to n of EI. I goes from 1 to n. The complement of that is everything that's not in the union. It's everything but the union. It's everything but the union. This is the same as taking the intersection of the complements of the EIs. Notice that outside here, right there, there's no complement. What happens is you can change all three of these. Well, let me define three. And you can change the union to intersection. You can change the EI. Notice there's no complement here. You can change it to a complement. Notice that there's a complement here, so you don't put a complement. Those are the three things you change. You can change all three of them. And they're equal, and you can always change them whenever you feel like it. You can just go and change them. Let us prove this. I'm going to show that everything in here is in here. And after showing that, that can mean this is bigger. And then I'm going to show that everything in here is in the first set. Okay. So suppose X is an element of the union of EI's complement. Now, this is something. X is in the complement of it. Well, that means X is not in the union of the EIs as I goes from 1 to n. Remember, this means E1, union E2, union E3, etc. up to union En. X is not in here. Well, if you're not in the union of sets, you're not in any one of the sets. So this implies that X is not in the union of EIs. That is, X is not in E1, X is not in E2, all the way down to X is not in En. Okay, well this implies, well, if X is not in EI, then it must be in E1, I meant to say. It must be in E1 complement. If X is not in E sub 2, then X must be in E sub 2 complement. All the way down to X must be in En complement. Well, if X is in here, and X is in here, etc., and X is in there, that must imply that X is in their union of EI complement. Now, these arrows go the other way. If I start with this, if X is in the union of any set, I don't care what I call that, those sets, complements or not. If X is in the union of those sets, then X must be in E1 complement, X must be in E2 complement, X must be in En complement. That is, the bottom line implies the line above. Well, if X is in E1 complement, then surely X is not in E1. And if X is in E2 complement, then surely X is not in E2. And likewise, X is not in En. That is, that second to the last line implies the line above. Okay. Now, if X isn't in this set, and X isn't in this set, and X isn't in that set, well then X is not in the union of those sets. So the implication continues up. Now, if X is not in this set. And don't let it bother you what it's called. If X is not in this set, and I don't care what they call the set. If X is not in there, well then X must be an element of the complement, which is exactly what it says up here. So, if X is in here, then we showed X is in here. And likewise, if X is in here, this set, reading upwards, then X is in this set. They're the same set. If something's in one of them, then it's in the other, and vice versa. These two sets are equal. These two sets are equal. Okay. Now, we can play some games with this. Again, the names of the sets, they shouldn't matter. They shouldn't matter. What I'm going to do is, I'm going to change the name of the set. I'm still going to have the complement outside, but I'm going to change the name of this set. I'm going to call it EI complement. Okay, just the name. This is equal to the intersection as I goes from 1 to n. And remember, that's now EI complement. But we take the complement of it. So we just get EI. Now, what's in each of these brackets is the set. Now, in case you don't believe this, you have A, and now this is everything outside A. So if this in here, maybe I shouldn't be doing that. I don't want to draw inside, excuse me. If this is A inside is A. So then out here, that means not in A, out here is a complement. Let this be the universal set. So everything outside of A is called a complement. Well, the A complement is a set. And as a set, we can talk about the complement of a complement. We can talk about the complement of the set. Well, you see the universal set. It's everything in the box. And the black lines, that's where this set is. I don't care what we call the name. That's where that set is. Well, the complement of that will be everything else. Oh, look at that. It's A. If you take the complement of a complement, you get back no complements. You compliment somebody twice, it doesn't count. That's what it means. So don't give too many compliments. All right, so what am I saying? If I take what's in here is a set, and it says take the complement. If I take the complement of this, the whole thing, that vanishes. I just get the union as I goes from 1 to n of EI complement. And if I take the complement of this set, well, I get the union as I goes from 1 to n of EI complement. And this symbol should not have changed. Sorry. And again. Just want to make sure. So this here gives us another formula. And all I did was take the complement of both sides of the first one. The first one we derived more, somewhat rigorously. And this new one we got almost for free. So sometimes it'll be easier if you're given the union of sets. It might be easier to look at the intersections. Depends upon the problem, and we'll definitely come up against some in their next couple of sections. This completes this section on sample space and events. Remember, these EIs were events.